everyone. So today we are solving or looking for the answer to the essential question of how do we factor out the GCF or the greatest common factor when we have an algebraic expression. So looking at factoring, the word factor or factor the expression is going to be our vocabulary word today. Factoring an expression. So when we are factoring an expression, we are writing the expression as a product of factors. What in the world does this mean, Miss Englander? What does it mean to write an expression as the product of factors? Well, let's break this down a little bit so that we know. The word product means an answer to a multiplication problem. And factors would be the things that we multiply in the multiplication problem. So factors are what we multiply. So when we are factoring out an expression, we're working backwards to pull out the greatest common factor and create a distributive model. So essentially here we are creating a distributive model. So we are working backwards. They're going to give us the answer and we are figuring out the GCF to create the model. Okay, so that is what we are doing in this lesson. So let's look at an example so you can see what I mean. If it says to factor 24x minus 18 by using the GCF, our job is to figure out our two factors. So the first factor that we have is 24x. The second factor that we have is 18 or negative 18, which is what we want to end with. So our job is to factor out or create a distributive model that uses 24 and 18 as the final answer. So whatever we do at the beginning is going to give us an answer that's equal to 24x minus 18. So our first step we're going to look at is factoring. So we're going to look for 24x. So what are some factors that make up 24? Well, the factors that make up 24, some factors that we can use are 1 and 24, 2 and 12, 3 and 6, no, that's 18, 4 and 6, and then 5 doesn't go in, so these would be the factors, okay, of 24, plus the x. We don't want to forget about the x, so we're just going to put that x out there because whatever we use, we're going to multiply by x. Now we have 18 as our other factor, or our other number that we're going to use for multiplication. So to get to 18, we use 1 and 18, 2 and 9. There's our 3 and 6, 3 and 6. And 4 doesn't go and 5 doesn't go. So our greatest common factor, the number that they both have in common, is 6. So our GCF equals 6. Now that we know what our greatest common factor is, we're going to set up a distributive model. So 6 is our special number that's going to go on the outside of the parentheses. Well, to get to 24, remember I want this whole thing to equal 24x minus 18. So to get this first factor here, to make it 24x, I need to multiply 6 by 4. 6 times 4x, and that gives me 24x. There's my 24. And then I need a negative 18 or minus 18. So I'm going to subtract 3 because 6 times a negative 3 gives me negative 18. So here is my second number. So when I multiply, there. So my distributive model is the factoring the expression using the GCF would be 6 times 4x minus 3. I am ending with the distributive model. In our last lesson, we were given, lots of distributive models here. So in our last lessons that we did, we were given the distributive property and we had to factor it down to the expression. We're working in reverse now. They're giving us the answer and we're creating the beginning part, the starting part. Okay, let's look at example B. So example B that I have says 6x minus 27. So again, I'm factoring this using the distributive property. And so my first factor that I'm working with to find the GCF is 6x. So I want to look for the factors that make up 6x. And then I want to look for the factors that make up 27. So to make up 6, I know I'm going to use 1 and 6, 2 and 3, and that is it for that one. For 27, I'm going to use 1 and 27. And I'm going to use 3 and 9. And I think that is it. Those are the only ones. And if you look right here, you can see that 3 is our greatest common factor. So our GCF is 3.